Hello, everyone. Thank you for joining us. I'm Kathy Wells, Editor-in-Chief of OEM Off-Highway. Welcome to today's webinar, From Blends to Fittings, a comprehensive guide to biodiesel for on- and off-road equipment, presented by Natalie Hicks, Guillermo Gianni, and OEM Off-Highway. Today's session is being recorded and will be available on demand this week at oemoffhighway.com. A couple of tips before we get started. Our presentation today will feature slides with live audio from our presenters. You'll note that your view within the system is customizable, so please feel free to adjust the layout and engage with different windows to meet your viewing preferences. You may submit questions for our presenters at any time during the presentation using that Q&A section on your screen, and we'll answer as many of those as possible. And last but not least, please be sure to check out the related content section for some additional information and really helpful resources there. Now, today's webinar is sponsored by Parker and will explore the benefits and challenges of biodiesel, helping on and off-road OEMs understand how it can enhance operational efficiency and sustainability. Parker is a Fortune 250 global leader in motion and control technologies. For more than a century, the company has been enabling engineering breakthroughs that lead to a better tomorrow. Now to meet our presenters. Today's presenters are Natalie Hicks and Guillermo Gianni. Natalie, Guillermo, thank you so much for being here with us today. So at this time, I'd like to formally hand over these controls to Natalie to get things started with some introductions and then begin the presentation. Natalie?
Thank you. Yeah, good morning and welcome to From Blends to Fittings, a comprehensive guide to biodiesel for on and off equipment. As our host introduced, your speakers today are myself, Natalie Hicks, a Division Sales and Marketing Manager at Parker Fluid System Connectors, and Guillermo Gianni, a Transportation Product Sales Manager, also at Fluid Systems Connectors. Between us, we have over 30 years of fitting and sealing experience. Our agenda today is to first review various types of biodiesel blends currently used in the market. We'll talk about some of the benefits and challenges of using biodiesel. We'll review some component consideration and introduce Parker's method of material selection called stamped. Fitting and plating options will be discussed and how to select the best combination for your process. And we'll finish up with key takeaways. So first, let's review biodiesel fuels. There are a variety of biodiesel blends on the market. Biodiesel blends are mixtures of biodiesel and petroleum diesel. The B designates it as a biodiesel blend, and the number after the B indicates the percentage of biodiesel in the blend. The most commonly used biodiesel blends are B5, which is the 5% biodiesel and 95% petroleum diesel, and B20, which is the 20% biodiesel and 80% petroleum diesel. B5 is commonly used because many diesel engines are designed to run on it without any modifications. This makes B5 attractive since users can use their existing engine and still get a reduction in emissions. B20 offers a good balance of costs, lower emissions, and cold weather performance and engine compatibility. This is the blend most often used in fleets. As you can see on the right, there are a variety of other biodiesel fuels that increase in biodiesel content. The higher the percentage of biodiesel in the fuel, the higher reduction in emissions you can expect. But it also leads to more complications in the engine, which we'll talk to later. The higher biodiesel percentage requires modifications to traditional diesel engines and are less reliable in cold weather. For example, B100, which is the purest of the biodiesels, has 100% biodiesel and 0% diesel. It has the highest reduction in emissions, but it also requires the most engine modifications. It would also be noted that it's the most unreliable in cold weather. In the following slide, we'll take a look at the relationship between bio percentage and reduction in emissions. So how much reduction should we expect to see by migrating to biodiesel? The graph here represents what can be expected. The y-axis is the percentage change in emissions in moving from diesel to biodiesel. The x-axis is the percentage of biodiesel, the B5 and the B20 and the B100 fuels that we just talked about. The arrows indicate the rate of the lowered emission. From the graph, you can see how much reduction in hydrocarbon, carbon, monoxide, and particulate matter there is, the higher the percentage of biodiesels that is blended into the fuel. The higher the percentage of biodiesel, the less the emissions. On the previous slide, we talked about B20, one of the more commonly used biodiesel fuels that are often used in fleets. According to this graph by the EPA, we can expect a 22% reduction in particulate matter and a 15 to 8% reduction in hydrocarbon and carbon monoxide. The most pure biodiesel, which is there on the far right, B100, has a 74% lower in particulate matter and 55% reduction in hydrocarbons and carbon monoxide. This meaningful reduction in emissions is what makes biodiesels an interesting to explore as an alternative sustainable fuel. I'd be remiss, though, if I didn't mention an ongoing debate regarding the biodiesel fuels currently on the market. The food versus fuel debate centers on whether increased biofuel production, particularly from food crops like corn and soybeans, negatively impacts food security and prices by diverting land and resources from food production. The three primary arguments for the food versus fuel claim are: one, land use. Biofuel production, especially using first-generation feedstocks like corn and sugarcane, requires significant land area. The second is resource competition. Biofuel production competes with food production for resources like land and water and fertilizers. And lastly is increased food prices. Proponents of this view argue that diverting food crops to biofuel production has contributed to increased global food prices. In response to this debate, microalgae could be a promising option among third-generation biofuels. We'll take a closer look at this option on the next slide. Algae-based biodiesels are renewable fuels derived from algae, a diverse group of photosynthetic organisms that can grow in a variety of environments, including freshwater, saltwater, and even in wastewater. These biodiesels represent a promising alternative to traditional biodiesel sources. Here are a few benefits. First is the high oil content. Many species of algae can contain significant amounts of oil, often ranging from 20 to 50% of their total biomass. This high oil yield makes algae a highly efficient feedstock for biodiesel production. Second is low land requirements. Algae can be cultivated on non-arable land, including deserts and saltwater areas. Third is algae can grow much faster than traditional crops, with some species doubling their biomass in just a few hours. This rapid growth allows for more frequent harvesting and higher overall oil production per area. Then there's a benefit of carbon dioxide absorption. Algae absorb carbon dioxide during photosynthesis, which can help mitigate greenhouse gas emissions. In addition to biodiesel, algae can be processed to produce other valuable products, including animal feed, food supplements, and bioplastics. And lastly is nutrient recycling. Algae can utilize nutrients found in wastewater, making them an effective method for treating waste while producing fuel. The benefits of biodiesel in equipment application can be categorized in three groups. The first is the environmental impact. Using biodiesel contributes to reduced greenhouse gas emissions compared to fossil fuels, promoting sustainability and supporting manufacturers' environmental goals. As we saw on a previous slide, using biodiesels can lower carbon dioxide emissions by up to 74% compared to traditional diesels. The second is biodiesel is a renewable resource. Biodiesel is produced from renewable resources, which can enhance a manufacturer's reputation as a sustainable and forward-thinking company. Third is sustainability. By encouraging the use of renewable feedstocks and reducing environmental footprints, biodiesel aligns with sustainability goals for businesses and industries. It's an added benefit that biodiesel can be used in existing diesel engines and distribution systems with little or no modifications, facilitating a smooth transition to more sustainable fuel options. There are many industry challenges with using biodiesel fuels in current engine designs. The first challenge is material compatibility. Biofuels can be more corrosive than traditional diesel, requiring components made from materials that can withstand its chemical properties. We will dig deeper into this on the next slide. Next is temperature sensitivity. Biodiesel has different viscosity and flow characteristics at varying temperatures, which can affect the performance of the fuel systems. Storage and stability is another challenge. Biodiesel degrades over time, especially when exposed to moisture and air. Therefore, care has to be given on how to store biodiesel to make sure that sediment formation and microbial growth does not occur. Adhering to the regulatory standards that are specific to biodiesel fuel is another concern. Requirements for compliance vary by region, so this is something that also has to be taken into consideration. Performance variation of biodiesel varies depending on the feedstock and production variants, and this is also something to take into consideration. Lastly is reliability, particularly in cold environments. Fuel injectors, pumps, and filters may require more frequent maintenance or replacements to ensure reliability. Now to discuss a little further on material compatibility. Biodiesel blends are not without its challenges. One major challenge is that depending on the biodiesel blend, any type of fitting used in the engine using biodiesel can be highly corrosive to your engine. The bar graph illustrates common metals and how quickly they corrode when exposed to various diesel-biodiesel blends. B100, as you probably remember from previous slides, is 100% biofuel and, not surprisingly, is the most corrosive to a variety of metals. B0 on the far left is 100% diesel and the lowest corrosive rate. Copper is the most impacted by the change in blends, while stainless steel and zinc are the least impacted. This graph points to the importance of considering the biodiesel blend when making a material selection for your fuel fittings. I'll also note that the graphs here are not taking into consideration plated fittings, which we'll also talk about. The biodiesel market is evolving in many ways. As regulations around emissions tighten and the demand for sustainability practices grows, more and more fleets are adopting biodiesel. Innovations are enhancing the performance and efficiency of biodiesel trucks, enabling them to compete against their traditional diesel counterparts. The expansion of biodiesel fueling stations is making it easier for truck operators to access biodiesel. Government incentives and mandates are encouraging the market to adopt biodiesel. There's an ongoing research and development into feedstock alternatives to make it more sustainable and economically viable. And lastly, is consumer preferences. As consumers become more environmentally conscious, there is growing demand for companies to adopt greener practices, including the use of biodiesel in their fleets. The standards and regulations for biodiesel applications can vary significantly worldwide due to differences in environmental policies, safety requirements, and industry practices. I'll highlight the United States and Europe as those are the two that are most applicable to this audience. In the United States, the Environmental Protection Agency, EPA, regulates biodiesel through the Renewable Fuel Standards, RFS, which mandates the use of renewable fuels. States may have additional regulations, such as California's Low Carbon Fuel Standards, which sets specific emissions targets. In Europe, the European Union has established the Renewable Energy Directive, which is RED, which includes sustainability criteria for biodiesel production and use. EU countries may adopt their own regulations, leading to variations in implementation and compliance. So with that, I'll hand it over to review component selection to Guillermo.
Thank you, Natalie. So I will be talking a little bit about component selection. We're going to divide that into slides, mainly talking, performance and also the contamination portion, which is very important to consider when selecting a component. So on the performance side, material compatibility is very important. Biodiesel can be corrosive, making it essential to choose components made from materials that can withstand chemical properties. Not only the material compatibility, but also the temperature resistance. Depending on the location where your application is going to be at, right? If it's closer to the engine, it's going to be, at another location in the engine. That's something that you need to take into account. Along also with the pressure ratings, depending also on what part of the system are you located at, or are you selecting components for. That's a very important part of considering the performance of a component. And also very, very important, and we're going to be discussing this in a little bit more depth, sealing integrity, which, choosing the right sealing material helps ensure a secure and leak-proof connection. If you don't choose this, all of these components or all of these variables correctly, you won't have a successful connection or a successful system. Why do we pay attention to all of these variables? Well, it's about contamination. So material compatibility and the chemical resistance of the material you choose is essential. The materials must resist microbial growth under biodiesel conditions. Also take into account the surface finish. So Natalie spoke about all of the different metals, right? And their reaction to biodiesel, but also, we have some options or plating options that could work. And the surface finish is also, very important to consider, and platings play a big part on that. The installation practices is if your component or your fitting is going to be, located in a highly serviced area, then, you may consider something that's quick to connect and disconnect. If it's going to be something more in depth in the engine, or more, let's say, in a very deeper location in the engine, maybe a more robust connection may be chosen. And again, seal integrity is crucial, right? The seal compatibility with biodiesel is vital for your system to work. Overall, the choice of materials for your components in biodiesel applications is significantly impacts the contamination levels you're going to be looking at in your fuel system in general. So fittings per se play a very essential role. It is part of your design. They're part of a system, right? Fittings are a subcomponent of a system, right? But properly designed connections ensure that the fuel delivery systems operate smoothly, right? By taking into consideration all of these variables we spoke about. Also, the connection type, that's, different connection types can handle varying pressures or flow rates, or, depending on what you're trying to, put this fitting on, like a service side or maybe a permanent fitting, right? That also plays into account when considering connection type. And, material compatibility. I think that material compatibility you'll hear about material compatibility all across all of this presentation, because it is crucial to select the right material and also surface finish in that case. So how do we select the fitting? Parker Hannifin has a recommendation to not only biodiesel systems, but any other system you work with. So if you're in the process of selecting a fitting, we use what's called an acronym called STAMPed that will help you select properly a hose or a fitting or a component in your system by taking into account the different letters here in this acronym. So I'm going to start with the S, which refers to size, right? What is the diameter size that you're going to be connecting to? What's the connection size you're considering for your system, right? You may have a T, you may have an elbow, you may have an adapter, right? So it is very important for you to consider size and select the proper sizes, and also the thread type, right? If it's going to be a straight thread, if it's going to be any other type of SAE thread, or any type of different connection type. The temperature for the T for temperature, that's basically very straightforward. What's going to be the temperature that is going to be operating in your application? So could be high temperature closer to the engine, could be maybe something that's medium temperature, right? So that is very important to consider, not only the external temperature, but also the temperature of the media you're conveying. The A for application, right? Where is this fitting going to be used at? If it's going to be, a service component, like I was mentioning, right? If it's going to be part of the filter section when you're servicing a filter, right? You want to take that casing out. Maybe you need a quick connect, right? So what type of application are you going to be using that fitting for? the material. Like I said, you're going to hear material a lot in this presentation, all over this presentation. So what is the material that it's going to be in contact with the media you're trying to convey, right? What's the substance? Are they compatible, the material that you're considering, in that substance you're trying to convey, in this case, biodiesel, right? So very important thing to consider. The pressure of the application, right? What is the maximum working pressure in that application? That will play along with your type of connection, right? If it's going to be a quick connect, right? If it's going to be a compression fitting, if it's going to be a barb, right? It really depends on what's going to be your pressure, operation pressure. Then we go to E, the ends, right? What type of connection will be interfacing with that fitting? Is it going to be transitioning from a maybe not in the biodiesel example, but for example, if you're transitioning from NPT to a straight thread, or if you're transitioning from a quick connect to a compression fitting, right? What type of ends on the other side you'll be interfacing with, and also the delivery, right? When is the hose assembly required by, and does it have to be tested as a system, right? Is it something that should be pressurized as a system? Is it going to be something that's going to be serviced, right? So using the stamped method will help you properly select any component in your system, not only a fitting, but since we're reviewing biodiesel application, right? It is very important and recommended that you use the stamped method. So the material choice, right? Again, material is very important for biodiesel applications. It is a technical decision that has a lot of variables to make a decision whenever you're choosing a material, right? So you have to take into account the compatibility of that fitting or application, the durability and longevity, right? Accessibility, I would say, as well, safety and reliability of your application, if it's going to be exposed to external components or forces, right? The thermal stability, right? That expansion contraction of a fitting, right? Or maybe the place where it's located at, maybe it's going to be exposed to other exterior components. Environmental and regulatory compliance, right? There's certifications out there. There's also customer specific requirements, right? To make sure that you're aligning with what your design is going to be taking into account, any parameters you should be taking into account, the performance optimization, and also the cost effectiveness. Now, at the end, the component you're choosing, right, is going to have to be sourced somewhere. So if the cost effectiveness is important for you, which nowadays it is for everybody, right? That's something that we have solutions for. So we'll review those later. So material compatibility, we have the option of using some different materials, right? Biodiesel is very corrosive, and more so than traditional diesel. So when designing your system, right, you'll need to take into account which types of materials you're able to use in these type of applications. So we have composite materials, which is mainly thermoplastic. You have the option of using also electroless nickel plated brass, and stainless steel, which is has very high compatibility and performance in an overall several number of applications. So in this slide here, this chart shows you the comparison side by side on each one of the different materials. So you have on your left, you have composite, you have electroless nickel plated brass, and also stainless steel as a third option. So as you can see, and it comes as a no surprise here, composite is going to be lying at a more cost-effective solution, right? Compared to stainless steel. Stainless steel by nature is is just it's an expensive solution. It's a good solution, performance wise and technical wise, but it's also very costly. When it comes to connection speed, composite has different types of connection types, but mainly I'm gonna be focusing on the J2044 type of fitting, which is a quick connect, right? Compared to electroless nickel plated brass, which is typically more around compression fittings or barbs as well, right? And on the stainless steel side, you can have the same type of fittings, even a compression type fitting, or maybe a threaded fitting or a barb fitting, right? But it's going to be made out of pure stainless steel. On the corrosion resistance side, all of these three materials are classified as as perfect performance on the chemical compatibility with biodiesel. So all of those three are good depending on your application. That's the caveats you need to take into account. The durability side, composite naturally has less, I'm gonna say, resistance compared to a metal fitting, right? Depending on the application you're trying to use it for, but it will excel under other circumstances where you're not looking for durability or that mechanical performance that you're trying to look for. On the weight side, though, composite is a winner, right? It is going to be substantially lighter compared to brass and stainless steel, which are very comparable in weights. The density is way higher than the composite, of course. Temperature limitations. All of these fittings have excellent temperature limitations. You may assume that composite doesn't have a good temperature limitation, but we do recommend certain type of temperature applications. We do recommend composite as well. So all the three of them have excellent temperature limitations. Pressure limitations, again, this has to do with the type of connection you're dealing with. If it's a quick connect, it's going to have a lower pressure rating compared to a compression fitting or any other type of connection. And last but not least, configuration limitations. We have composite classified as red here just because if you're trying to look for a customized fitting or solution, you're going to have to invest in tooling ahead of the product. So what that means is that once the design is locked, then the tooling is going to only produce that type of configuration fitting. What's the advantage on metal fittings? You can configure them, right? We have blank tees that can be, we can play with the different configurations on diameter sizes or connection types, right? The same with electroless nickel plated brass and stainless steel, right? If you're trying to configure a certain type of connection, you're able to do so without the heavy investment at the beginning. So talking about fitting connection types, I've been pointing out, these three different materials. The composite mainly centers around quick connect fittings, right? Quick connects are designed to an easy and rapid connection, right? If you're installing a filter or if you're considering that component to be part of a servicing site or a servicing application, then a quick connect is the right solution, right? If it breaks, if it's somewhere accessible, right, you can easily disconnect it and connect it, right? If you're trying to service a filter, if you're trying to service a hose, right, that the quick connect type of fittings are recommended in this type of application. Compression fittings, compression fittings have existed for a number of years, a very long time ago. And they're very, I'm going to say robust, right? And they're very guaranteed type of connection when dealing with, metal fittings, right? The same thing goes for barbed fittings. If you're using it for a hose, right, you're connecting it to a hose interface, barbed fittings is an excellent option that you can use for these types of applications. So going more in depth on the types of connection types, the quick connect fittings, right? What are the pros? They're easy to use, right? They have a reduced downtime, right? If you're trying to replace something, it'll be easily replaceable. or easy quick disconnect, right? It has a leak-proof design, right? It is versatile. It's a versatile connection. You can put it in and configure it in several types of fitting types, like an elbow or a straight fitting or a T fitting, right? It is a safe connection. It is a very proven connection, the J2044, and it's a space-saving design, right? Being designed out of a composite or thermoplastic, right? It allows us to work on the design to make it compact and to leave certain space for serviceability, right? On the con side, wear and tear, it's a thermoplastic at the end of the day. If you hit it too hard, or if you're, constantly connecting, disconnecting, it's going to have a life, right? Depending on the number of connections and disconnections, or the treatment that you give to that fitting. It has limited pressure ratings, of course. It being a quick connect, it's not going to be a fitting that's robust enough to withstand higher pressures. There's going to be compatibility issues. So what I mean by that is that if you're trying to interface with another type of connection, so if you're going from a quick connect to a metric thread, you're gonna struggle. It's not gonna be something that you'll find off the shelf. It's a customized, or it would be considered a customized solution. So compatibility issues is something to consider. The cost. So we put a cost as a con only due to the fact that if you're trying to come up with a customized solution, is going to cost you money on the tooling side. However, cost-wise, on an off-the-shelf part, it's gonna be more cost-effective than other types of solutions or metal solutions in general. And configuration challenges, right? We typically see quick connect fittings as an off-the-shelf offering for our customers. So it comes with configuration challenges. If you're looking for something very specific and customized, yeah, it's going to be a struggle. On the compression fitting side, the pros, it's a leak-proof seal. It's easy to install, right? It is durable. It is a very proven connection type, right? Minimal tool requirements, and it is very compatible with a lot of connection interfaces, right? So if you're trying to go from compression connection to an NPT thread or a straight thread or any other type, even barb on the other side, we're able to play with that. We're able to configure different types of configurations there. On the cons side, we have a limited temperature range, right? It highly depends on the seal, right? Limited pressure ratings as well, compared to other types of connections that are more robust. The size limitations, right? Compression fittings typically go up to a 1/2 inch, right? After 1/2 inch, you'll need to use another type of connection, and it's typically, lower pressure on that side. And the installation complexity. So if you're trying to put this fitting in a very hidden location inside an engine, right? You'll struggle a little bit to get the tool in and try to, tighten or untighten that fitting. So, it's there's different type of variables that you need to consider when selecting compression or quick connects. Now talking about barb fittings, right? It's easy to install. It's very known in the industry and across many industries, right? It is a very versatile type of connection. High compatibility in terms of like connection types. If you're trying to transition from a barb fitting to any type of thread, that is very doable, and the cost is not as intimidating as investing in tooling for plastic or thermoplastic fittings. It is lightweight typically, right? They're not that big of fittings, right? Depending on the size, right? And it's widely available, right? Once you know your hose ID or your barb size, it's widely available, right? The cons, limited temperature range, right? You're playing with a barb and a hose, right? That's basically the interaction between those two. Basically relies on on how much pressure and temperature that hose and barb fitting can withstand. That's basically your limit, right? Your threshold. and enhanced maintenance, right? Typically, barb fittings are used in conjunction with a hose, so you'll typically have to check for leaks, check for if that connection is properly done or not done, right? So it requires enhanced maintenance compared to the other two types of connections. Now I'm gonna pivot a little bit. I'm gonna be talking about sealing solutions. So as I mentioned, we went through material, we went through connection types, right? Sealing solutions is also very important to consider because they're all links in a chain that if you have the incorrect or a weak link in your chain, it is gonna fail. Your selection component selection is gonna fail. So choosing the right seals and fittings that are compatible with biodiesel, it is very important, right? You have to consider the compatibility of the seals materials, right? You need to make sure that the materials resist degradation from biodiesel and its blends, right? The operating conditions, if it's going to withstand the temperatures that your application needs, right? Temperature, as I mentioned, right? You need to consider that as one of your variables to consider. Pressure and also the exposure to contaminants, right? If it's going to be exposed to dirt, water, or anything that may compromise the seal integrity and performance. So, talking specifically about sealing solutions, when talking about fittings, and you're trying to select a component, you already have the material, you already have the connection type, right? The main two best choices that you can choose for your connections when dealing with biodiesel are two: PTFE O-rings, right, and FKM O-rings. Both have excellent compatibility and temperature range performance. Depends on what you are going to be using them for. PTFE, Teflon has excellent. It's a low friction type of material that will, help you in certain types of applications. And on the FKM side, durability is one of the things that this compound excels at. So, those are the two main components. Which sealing types you should not use? So, what type of seals you can't use with biodiesel? Those are nitrile, right? You gotta watch out. A lot of fitting solutions out there have nitrile as their seal type, mainly because most fittings are designed for water and air, right? Nitrile is excellent on water and air, but not for biodiesel. Polyurethane, natural rubber is another popular one, and neoprene, right? These four sealing solutions, if you ever see that the fitting you're trying to select has any of these seal types, ask questions, see if you can replace that seal compound for FKM or PTFE. So your sealing solution is correctly chosen. Now, we've discussed material, connection type, seal solution, and then plating, right? You see that picture on top there. That's how your system is going to look if you don't choose your components correctly, right? I'm just joking. So plating is, it's a very good thing to consider, right? Not only the material type is good, right? But when selecting fittings for biodiesel application, you need to consider also the plating options, right? There's many plating options. I'm gonna discuss about the main three or the most popular ones that are out there, depending on the metal material you're trying to choose. But going a little bit in depth on the plating options, right? We got the zinc plating, which is very effective and economical. It is not an optimal type of plating, right? It oxidizes very quickly when exposed to biodiesel. So zinc plating is out of the chart, right? Zinc nickel plating, very used with steel, right? It offers an excellent corrosion resistance, making it highly suitable for biodiesel applications. So zinc nickel plating for with steel it's a very good solution if you're looking to use a steel fitting. And the electroless nickel plating option is a superior type of plating. We use it with brass and other types of metals, right? It provides a uniform coating that enhances corrosion resistance and wear properties. And that actually is done not only on the outside of the fitting, but also on the internal side of the fitting where the biodiesel is going to be in contact with your material. So what is E&I plating? So E&I is short for electrolysis nickel plate. So it is a process, it is a chemical deposition process where nickel phosphorus alloy is deposited onto a substrate without the use of electrical currents, right? How do we do that? We do it through an immersion process, right? So we take that fitting, we immerse it into a chemical bath, right? And this chemical bath will have this fitting uniformly coated on the inside and on the outside, right? So you won't have to worry about if it's going to be affecting the the metal that's going to be coated with that finish, right? It is a very highly recommend plating, right? And it has excellent ratings and compatibility with biodiesel. It is corrosion resistant. It is has enhanced durability. It also uniformly coats complex geometries, right? If you have a weirdly shaped fitting, right, you're able to coat that with E&I. So there's no limitations to that compared to other types of platings. So just to round it up a little bit, just to wrap all of that information, right? When specifying the right biodiesel fitting solution, it is very important to consider your options, right? And determine what's best for your application. So gotta remember that biodiesel has been increasing in popularity around the world, right? So it is gonna be, used more and more depending on the country and region you're at in the world, right? It is something that has been gaining a lot of popularity, mainly for its sustainability features, right? The benefits and challenges, right? You gotta consider when working with biodiesel that it comes with its challenges, right? Selecting the proper components. The biodiesel is highly corrosive. The biodiesel has a limited shelf life compared to other types of fuels, right? There's different benefits and there's different challenges, right? Benefits, very sustainable. It has the byproduct of a combustion for biodiesel is has lower emissions, right? So there's benefits to that, but also comes with its challenges. How to choose the right componentry to for your application. Our main recommendation is for you to use stamped, not only for your biodiesel applications, but for all of your applications that require selecting a component or a fitting, right? And of course, last but not least, please consider plating, right? It is an excellent option when trying to have the advantages of stainless steel, but at a lower cost. So if your goal is to have a metal fitting with certain type of connection type and with the performance of a stainless steel fitting, electrolysis nickel plated is a good option. It is a recommended option for biodiesel applications. So in general, Parker Hannifin, right, has been solving the world's engineering problems. But as industries shift towards renewable fuels like biodiesel, the demand for durable and cost-effective fuels fitting will continue to rise. It's on the uptrend. So Parker is poised to be your partner of choice in this transition, right? Offering innovative solutions that meet evolving needs of the market. Together, we can drive efficiency and sustainability in your operations. So we'll help you if you want to discuss, options for your applications. We'll help you, and we have, a robust, very capable teams, engineering and quality teams that can help you select and work with your solutions or applications. So talking a little bit about what we can do at Parker FSC or Fluid System Connectors Division. So Parker Hannifin, specifically Fluid System Connectors Division, is the industry leader in brass fittings since 1960. and it has been the industry leader in thermoplastic fittings and valves since 1969. Actually, the quick connect technology that you're very familiar with when doing with air braking quick connect fittings or J2044. So those type of fittings were pioneered by Parker back in the 60s. So we have tons and years of experience on with these type of connections. So like I said, just summarizing, right? You have your your compression type biodiesel fittings, which we would electroless nickel plate that body and its interior, right? You can withstand pressure ranges from up to 150 psi or 10.3 bar, right? Temperature wise, up to 200 Fahrenheit or 93 Celsius, right? On the SAE J2044, which is your quick connect, your what we call safe lock. It's made out of thermoplastic. You can withstand up to 72 psi of pressure rating or 5 bar and 239 Fahrenheit or 115 Celsius on the temperature side. And of course, valves, right? Valves, we have tons of options, tons of customized options as well. If you're going through a barb or a metric fitting or a metric and straight to NPT, we have many options, right, in configurations. We would do those in electroless nickel plated brass, right? This range can withstand up to 600 psi or 41 bar in pressure rating and up to 350 Fahrenheit degrees or 176 Celsius degrees. So those three options are very, very good options for biodiesel applications, right? If you give us a call, send us an email, we can help you with your application and your project while revising the characteristics and requirements of your projects. So again, one of our main capabilities from our Fluid System Connectors division is our customization options. So we have a US-based engineering team, right? And it is locally manufactured to Euro specifications. We use the stamp process on all of our designs to customize your product, right? And we have the capability of customizing any type of connection and fitting, right? So if you're going to a barb, to a metric, from a metric to an NPT, from a compression to an NPT, we can do it. And we can also offer a very number of options when dealing with this. So with that, I'll pass it on to Kathy, who is going to be helping us on the next stage.
That is perfect. Thank you so much, Guillermo. This is such an interesting topic, which has brought in quite a few questions from our audience today. But quickly, before we get to those questions in our Q&A, Parker would love your help in pinpointing the topic of its next webinar. So to do that, we'll quickly share a poll here with you to have you share your thoughts on this. And it's a simple question. Which of the topics listed here would be most of interest to you? Take a look at those responses and go ahead and cast your vote for the topic you'd like to see most in an upcoming webinar from Parker. We'll leave this up for a minute more so you can get those votes in, and then we'll kind of take steps toward the Q&A. And just to walk through some of those topics, are you more curious about benefits of straight thread O-ring to push to connect fittings and DOT applications? Maybe you're more interested in how custom manifolds can remove leak points and simplify plumbing or utilization of check valves. Another good option is shuttle valves and pressure protection valves in DOT applications. And lastly, the last option there is diesel fuel systems, specifying and using aluminum fittings. We'll leave it up for a couple more seconds and then we'll kind of hit the road here. Okay, thank you so much for your responses there. I think before we jump into the Q&A, Natalie, I believe you had a few more points to address.
I just wanted to say thank you, and I hope you found our discussion on biodiesel fuels and the importance of selecting the right fittings for biodiesel applications informative. And we'll get into the question and answer here, but if you would like to reach out to one of our engineers or you just need more information, our website is there with www.parker.com/biodiesel_fittings, and we are there to help and answer questions as well.
Perfect. Thank you, Natalie. So at this time, I'd like to go ahead and begin the Q&A. Natalie and Guillermo, we've got a great crop of questions here from our audience, so we're just going to dig right in. Why don't we start with, what are the known effects of biodiesel exposure on unplated brass fittings? Who would like to take that?
Natalie, do you want to take that one, or should I?
I can take that. Some of the
Okay.
known effects on the brass fittings are that we start to see some oxidation. So there's a couple different testing standards or protocols that we use to assess the compatibility of fittings with the biodiesel. One thing that we do is fully immerse the fitting with the components into the fluid. So typically we use either B100 because that's the most aggressive, as we talked about. You know, it has the most biofuel in it, all the way down to B0, which doesn't have any, just to be able to compare. And we look at how much of the metal has reduced over time. And sometimes we use weight, just a matter of, you know, how much weight has it lost over time. And then other things that we look at are how many millimeters of residue has come off, lost per year. And sometimes you don't have a year to test. So then we start to do an accelerated test with varying or increasing the temperature, the humidity, those types of things, to be able to accelerate the test and get an indication over a shorter period of time of how much of the corrosive happens with the metals. So in terms of the sealing components that are inside that, we do a similar test in that we use an immersion test. There is a little more standardization on that with ASTM. There's a couple of different test methods out there, like ASTM D7216 and AMS D4289. Those are common testing methods that are immersions for vulcanized rubber. And we use those, and sometimes customers just want just a straight up fluid immersion test. But those are generally, we're looking at in the immersion testing if it's gonna swell for the components, or if it's corrosing for the metal, corrosion over the metal. And then that's how we indicate, you know, whether or not it's applicable for whatever biofuel that the customer is looking to use. And what you would normally see, though, if it's not compatible, is severe corrosion on the metal over time, and that happens especially if it's not plated, because that it has, you know, for brass, it has a lot of copper, it has a lot of zinc in it. Those are the two main components of a brass fitting, and both are non-ferrous. So the oxidation occurs. We start to see, you know, some particulates, some sediment. Sometimes it's green in color, and that's an indication of it not being compatible. But plating is an option, as we discussed, to eliminate that chemical reaction happening with the brass.
Okay, great. Thanks, Natalie. We'll grab another question here. How about, are there any certifications or approvals for fittings used in biodiesel applications?
I can take that one. So no international standards per se. So we collaborate with a lot of OEM customers and a lot of companies that you know, use biodiesel engines, or you know, that design engines that will use biodiesel, right? That have that hybrid capability. And there are non-international standards. What we typically see is OEMs will have their own specific requirements. So they'll come to the table saying, like, this is what I need. These are the pressure ratings that I'm going to be working with. This is the type of biodiesel we're designing towards, right? These are the temperatures and locations of the equipment where we're trying to design, right? So they come to the table with specific customer requirements. There are, as Natalie mentioned, several type or methods to take a look of at what is the reaction of a certain type of material to biodiesel, right? Where you see the degradation of the metal, right? Of course, what's the main result of using the wrong material? It is contamination. So you'll see that in the interaction between the metal and the incompatible metal and the biodiesel will cause certain contamination, which will clog your filters or will clog certain types of components in your engine, injectors or whatever you're working with. So overall, no international standards, but there's customer specific requirements that we need to work with.
Perfect, thank you. Next up, we've got someone asking, how does biofuel adapt toward regular steel adapters or hardware in terms of corrosion?
Again, can you repeat the question, Kathy? I'm sorry.
Sure, that's okay. How does biofuel adapt toward regular steel adapters or hardware in terms of corrosion?
So in our experience, steel, or I'm going to say like a steel without the proper treatment or without the proper coating will react against, diesel and biodiesel in general. It does create contamination in your system, right? Biodiesel being more aggressive, of course. And depending on where you're using that, steel fitting, right? You will see some material degradation, which will end up, contaminating your system. That's what we've seen, and we do recommend plating or using, a different material option.
Okay, great. I'm going to keep us moving here. Next up is which testing standards do you use to qualify a particular fitting for biodiesel use?
So we do submersion of the component over time, right? The most typical biodiesel type is B20. That's what we've seen that most of the companies we've worked with, that's the B20 is the most popular option that they're going to be testing against. But we use B100 biodiesel to, we submerge the fitting, right? And you can see the degradation of the component over time. That's one way to do it, right? The swelling of the seal, right? Also, the weight loss on the fitting, right? If it's about the plating, for example, we check for the thickness of the plating, where we gotta design it for a certain thickness for these type of applications. But that's typically what we use for when testing fittings that are going to be in contact with biodiesel.
Okay, we have time for maybe just one more, so I'm going to squeeze one in here. What are the common failure modes of fittings used in biodiesel applications? How can they be identified earlier and maybe mitigated?
Most common, leaks. And the main reason is because they're not using the correct sealing type. And it is found on the earlier stages of whichever functional design. So it is something that will show probably over time. And when I say over time, maybe in the determined amount of months or days, right? But it's leakage. Leaks is the main common failure mode.
Okay, everybody, that does it for our time today, which brings our webinar to a close. I'd like to thank our presenters, Natalie and Guillermo, for their insights and expertise here today. And attendees, you'll be receiving an email from us very soon with access to today's playback and presentation. But please also feel free to visit oemoffhighway.com to check out more on this topic and browse other topics in our bank of educational webinars. But before you go, be sure to check out the related content section for additional resources and information there from Parker and OEM Off-Highway. Thank you again to our speakers, and thank you all for taking the time to join us. This concludes today's program.